Well, a major ocean current system that helps move heat around the planet may be weakening as the climate warms. That's according to research from Oregon State University, pointing to global consequences from rising sea levels to changing monsoon patterns. Meteorologist Joe Ranieri is here to explain how scientists are looking to the past to better understand what could happen next. Joe?
Well, Tim, the Atlantic Ocean is thousands of miles away, but the ocean currents could still be impacting us. Now, the system is called the Atlantic Meridional Overturning Circulation, or AMOC for short. It's a massive network of ocean currents that acts like a heat transport engine for the planet, and scientists say climate models show it could weaken in the future.
We hear a lot about El Nino and La Nina weather patterns, but there's one you probably haven't heard of.
AMOC, or the Atlantic Meridional Overturning Circulation, is one of the most important currents of the global ocean.
Crystal Bowsert, an associate professor at Oregon State University's College of Earth, Ocean, and Atmospheric Sciences, says the current plays a key role in the planet's overall heat budget.
This AMOC is very closely related to the heat budget of the entire planet, so not just the Atlantic, but the entire planet.
As our climate warms, he says models show the AMOC may weaken, and that's when the global waters and the planet warm up, leading to major consequences.
There's different implications. First of all, there would be the sea level. So we know that as the ocean warms, it expands. So that means sea level would rise around the world.
He says a weaker current could also affect other global weather patterns.
As AMOC weakens, for example, we find that monsoons all across Asia, the Asian monsoon, so that's the Indian monsoon, the East Asian monsoons, those monsoons tend to weaken, which has really big implications for the billions of people that live in those regions today.
If that happens, Bowsert says the oceans could heat up, speeding up global warming.
All the climate models that we have projected going into the future, this AMOC may be weakening.
To understand how the current has changed over time, scientists are looking thousands of years into the past.
We go to Greenland to drill ice cores, and these Greenland ice cores give us a very detailed record of the climate in Greenland going back in time.
Bowsert calls the ice a time machine because Greenland is so cold year after year of snow doesn't melt, preserving layers that can help scientists reconstruct past climate conditions. And while the current is strong right now, scientists are continuing to study it because measuring a current that spans an entire ocean basin is no easy task.
Now, you guys, scientists found that these natural shifts in the AMOC happened about 25 times during the last ice age, roughly once every 2,000 years. Now, researchers are now using ice cores and other data to better understand how the current could change in the future. And, joining us now is Chief Meteorologist Matt Zafino. You know firsthand how they do this research.
Yeah, about 20 years ago, I went to Greenland, went up onto the ice sheet, which was one of the most amazing things I've ever done, and did stories on the climate change research that they do up there, drilling those ice cores. And you land, we had to fly with the Air National Guard to get up there because there's no commercial air travel back then. And you land at 10,000 feet because the ice is 2 miles thick.
Wow.
And they drill those ice cores, and then the ice holds ancient air because there are air bubbles trapped within the ice. So they crush that ice and they analyze that air from 50,000, 100,000 years ago and see what the composition of the air of what the atmosphere was. So it really is amazing research. Now that AMOC current that you talked about, and it's a really important story, I'm glad you did it, that's connected to some deep water ocean currents that actually connect the Atlantic, Indian, and Pacific Oceans. And so it has implications, as you told us, all around the planet. It's pretty amazing.
And then you take all this information and research, and then hopefully you put it to good use to try and turn some things around, which obviously are going the wrong direction.
Well, yeah, that's exactly the whole point of that, too. But you got to understand what's happening first before you can come up with good solutions, too.
Yeah.
I did, however, just get back from Greenland a second time. This was a family vacation because now you can go to Greenland commercially. And this is,
look at that.
I was really hurrying to get some pictures and tried to get some video together from you off my phone. But we spent about 8 days cruising around southern Greenland in kayaks and in basically Zodiac boats and got up close to these icebergs, and they are amazing.
Hey, Matt, I want to interrupt you real quick, but since you went to the Greenland 20 years ago, did you notice a difference in the size of ice in 20 years ago compared to now?
So I was in two completely different parts of the subcontinent, if you will. It's a good question, though, Joe, and other people have asked me that as well. The first trip back in 2004, we flew to a town on the western edge of Greenland, landed at an old American Air Force base, which now serves as the research point, not on the ice, but off the ice for the National Science Foundation. There, the pilots and the researchers gathered and decided, okay, is it safe to fly up under the ice? And we did. So that was up on the ice sheet. This was in southern Greenland, which is a lot of fjords. But that picture I just showed you there, we are on kind of the southwest side of Greenland. That broke off the East Greenland ice sheet, floated down currents off the eastern side of Greenland, kind of like in the movie Titanic, and then made its way up the fjord. So pretty wild to see this stuff up close. Really, really beautiful.
Boy, I'll say.
It's another picture of one of those really giant icebergs that are floating around there. So it's a very important regulator of global climate, the Greenland ice sheet, and it's good. Exciting, and I hope you enjoyed Joe's story.